Well, ladies and gentlemen, we are moving towards the next set of panel discussion, and we're going to have a detailed insights on AMI communication technologies. Well, for our audience, this is going to be the most anticipated session of the day, and we have the moderator, Mr. Vincent, Thankachan, Solution Architect, Asia Pacific, Trilliant. The first panelist, we have Mr. Bhushan, Sethi, VP, Head NPD and Value Engineering IoT, Vodafone. Mr. Siddharth, Talawadekar, Head of Business Development, IoT, Airtel. Mr. Anand, Bhandari, Platform Head for Smart Metering, Geo. Mr. Jani, Vehkalahti, Global Head, Wirepas. And last but not the least, we have Mr. Rangel, Floranda, Solution Architect, Asia Pacific, Trilliant. So welcome everybody. And I hope
thank you very much.
Thank you. This session will be really, really amazing, the most awaited one. And now I look forward for the moderator to take it forward. Over to you.
Vincent, are you muted?
Okay.
Mr. Vincent?
Now we can.
Can you hear me now? Yes?
Yes, we can.
Yes, hear you.
Oh, sorry. So for that, I think it looks like my video is actually stopped. Okay, I'm not able to switch on. Okay. Good afternoon. Welcome you all for the last panel discussions of the day.
Mr. Vincent, we can't see you actually. We can only hear you.
Yeah, for just a minute.
Yeah. I think we can see everybody. Yes.
Am I visible?
Yes, I see you. I see everyone except Anand, and Anand is also back. But for some reason, I cannot start my video. Anyway, can I continue? Are you able to hear us?
Yeah, we can hear you very well now.
Hear you, sir.
Okay. Unfortunately, I'm not able to switch on my video for some reason. Good afternoon and welcome you all for the last panel discussions of the day. And looks like it's supposed to be like, we have got a big challenge addressing some of the key points to address on these communication technologies. Smart Meter National Program, actually, which has been rolled out by Ministry of Power, aims to replace about 250 million conventional meters with the smart meters in India over 3 years. Advanced metering infrastructure is seen as an important part of any smart grid initiative. AMI is a composite technology composed of several elements: smart meters, two-way communication networks, and a platform for the data collection and repository. Since morning, I've been actually hearing a lot about this particular smart meters and also on the communication network challenges, and mainly on the data collection part from AWS and Accenture. It was a great discussions we had in the morning. But let's go ahead and concentrate in today's panel discussions. We're going to compare various wireless and wireline AMI communication technologies and the role of LPWAN IoT technologies for smart meters. So let me once again introduce our panel members. We have Mr. Bhushan Sethi. He is the VP Head NPD and Value Engineering IoT. He's from Vodafone Idea Limited. Siddharth Talawadekar. He's the Head of Business Development IoT Airtel. Mr. Anand Bhandari. He is the Platform Head for Smart Metering Geo. And we have Jani Vehkalahti. I hope I pronounced it correctly.
Yeah, very well. Thank you.
He's a Global Head of Sales for Wirepas. And Mr. Rangel, Floranda, Solution Architect, Asia Pacific from Trilliant Network, Singapore. Welcome you all. Let's let's go through the first questions which I have for everyone. What are the communication technologies or LPWAN IoT technology offered by your company? So I will going to start with the Bhushan first. Bhushan, you're on mute.
Yeah. It takes time to, get it just to the new way of, doing the webinar and these seminars, Yeah, thank you very much, Vincent, and good afternoon to everyone. Very happy to be part of this panel discussion. Thank you, Smart Meeting Summit team, to invite me, and thank you, Vincent. Currently, I think as far as the AMI is concerned, as you rightly said, 250 million meters are to be lighted up in the next 3 to 4 years. Already we are seeing, initiative already being rolled out by a couple of distribution companies. We are seeing some actual implementation happening on the ground, and I'm very happy that we are, Vodafone Idea is part of some of these implementations which are happening, and this is the first time experience which we are getting on the ground. So I think currently the type of technologies which we are doing right now is 4G, 3G, and 2G. Okay, the type of data which has to be transferred is about just 5 to 10 kilobytes. If you look at DCRC, which is the most important thing, is just about 5 kilobytes of data. You look at billing data, it's about 60 KB, and maybe the daily data is hardly about 15 or 20 KB per day. So I think for this type of requirement, 2G and 3G are good enough. Of course, 3G is now phasing out. So currently we are working on 2G as well as 4G technologies. The beauty of 4G is that it automatically, switches back to 3G and 2G. So it naturally gives an added advantage to the customer. Thank you.
Okay, next we have actually Siddharth from Airtel.
Yeah, hi everyone. Firstly, thanks for having me on this panel discussion with all the esteemed guests. Great to connect with you all. Yeah, so Vincent, to answer your question, see the way Airtel is approaching is this is we are trying to solve customer problems with the right technology. So when I talk about Airtel IoT, it's an end-to-end platform with the ability to manage billions of devices and applications, right? At the core, at the end of the day, today, I mean, everyone knows about it. We have 2G, we have 4G network as well. At the same time, Airtel's network is ready with 5G as well as NB-IoT, right? And we are also investing in newer technologies like satellite communication via OneWeb, which you would have seen in the news as well. Coming specifically to the AMI piece, which is a topic of discussion today, I think today 2G is present across India. It is highly relevant. It is a mature technology. It has been tried and tested for utilities where, again, millions of utility meters are already live on the 2G channel, right? Now, at the same time, NB-IoT is also upcoming. And as I mentioned earlier, our network is NB ready. From an NB standpoint, we are currently focused on creating the complete ecosystem by partnering with device manufacturers, chipset makers, module manufacturers, SIs, and so on and so forth, right? And we have created some live setups across a few cities where we are seeing customer demand. So it's all customer backwards for us. Wherever we're seeing demand, we are going after that. We also have device testing capabilities, available to test it on newer technologies. Again, to reiterate, it's important for us, for our customers to have flexibility and options to choose from, and accordingly, we are, rolling out technologies which serves their use cases. Thank you.
Okay, then we have next is Anand from Jio.
Hey, good afternoon, everyone. Thanks, Vincent. And well, to answer to the question that which LPWAN technology that Jio offers, the answer is pretty straightforward from Jio's perspective. When we talk about LPWAN, NB-IoT is the only answer that we've really, we have as of today on the table when it comes to cellular options. Of course, there are other options like LoRa and RF, which work in terms of LPWAN. But we believe that because of the network infrastructure, the cellular network infrastructure that's already present in the country, LPWAN is one of the most efficient and upcoming technologies available as of today. And we are proud at Jio that we've launched NB-IoT throughout the nation. All our 300,000 plus cellular towers are radiating NB-IoT, which is capable for connecting any type of meter, not just electricity meter, but when you talk about LPWAN, again there comes gas, water, and all these things are battery optimized. So having a right fit of technology for multiple smart utilities is the goal with NB-IoT in picture. So the answer to your question is yes. The only LPWAN technology we offer today is NB-IoT, and there are further nitty-gritties and advancements that we have come. I'll walk you through those in the subsequent sections. But NB-IoT is not just 4G capable; it's also 5G ready. It's being adopted by 5G as one of the standards that will be coming. So we are not just ready for today, but we are ready for future as well.
Okay, thank you. We do have Jani from Wirepas.
Okay, so good afternoon, everyone. Thank you, Vincent. So I'm presenting the Wirepas, which is a Finnish company, and we provide the RF mesh as a protocol stack. And most of the people in the market might expect the Wirepas to provide an end-to-end solution. We don't. We believe at this kind of agenda like made in India. So we are licensing the protocol stack and let the local companies to build the end-to-end offering to fitting to the AMI needs. What comes to the service and the NIC cards, everything can be done in India. We only license the protocol stack. And what matters in a protocol stack in a RF mesh is that the two things: the total cost of ownership throughout the lifetime of the metering or the reading is the lowest. And the second thing is the reliability. And actually those goes hand in hand. In order to build a reliable communication, it also drives that in a best cost point. And we also are 5G ready. So today in India, we provide the 865 offering, but we are also providing now the 5G, which we launched last year. So it's a cellular radio based, but you don't need it's a kind of LTE-M type of radio, but you don't need the operator. So there is no subscription fees related. And the second thing is that with Wirepas, you don't need the network management. So these two things are driving the cost down, but we will come to that later.
Okay, lastly, we have Rangel, Floranda.
Thank you, Vincent, and good afternoon, everyone. So Trilliant is actually a connectivity company. We are experienced in hybrid wireless communications, primarily on private wireless technologies. So that includes our multi-tiered, multi-technology network in 2.4 gigahertz, as well as 5 gigahertz ISM license-free band. So primarily it's in a private environment, on a private wireless connectivity. This is a bit different from public communications like the cellular network and solutions. But we also support third-party cellular-based solutions in terms of integrating it to our backend system. So we believe that, I think Mr. Bhushan mentioned about capacity of going for 4G and even 5G. We also understand having that connectivity and capacity, wherein our RF Mesh 1 can support of throughput up to 270 Mbps on a private wireless network, considering the utility would have a preference on private versus public or have a combination of both. So it doesn't only solve the applications for AMI, but it also solves applications such as substation automation, distribution automation, CCTV, and even security surveillance within the substation itself. So it goes beyond your AMI. And we also support LPWAN for battery operated and remote applications. So we have a combination of mesh and a point-to-multipoint LPWAN solutions. And in addition to the cellular-based AMI, which we have generally deployed within in India, where we are supporting using our backend system, we also pride ourselves as the true device-agnostic communications company, as our standard-based integration program supports expansion that allows true interoperability with any meter model. So to date, we have 42 meter types across 22 meter bands on Trilliant network in Asia alone. So considering these are all IEC-based meter, both in RF solution as well as third-party cellular-based applications. So it doesn't matter whether it's NB-IoT, whether it's 2G, 3G, 4G, or even 5G. So we are device agnostics from a back-end system configuration.
Thanks, Rangel. In fact, if you look at the members on the panel, actually we have a good representation from the cellular companies, and we have two panelists from actually RF mesh solutions. Unfortunately, we don't have anyone from the PLC background. I hope no questions comes over that. And going forward, actually, I would like to ask each of you, what are the factors and challenges to be considered for the deployment of these technologies, considering that we are looking at 250 million rollout plan in India? So I will again start with Bhushan first.
Yeah, thank you very much. Always good and bad to be the first one to answer the question. Thank you. So I think there are a couple of factors to be considered before the deployment of the technology. As I mentioned earlier, we have zeroed down on 4G and 2G. We evaluated NB-IoT very, very closely. But in India, what technology was originally made for once in a while communication, once in a month, once in a day, types of applications. But when we look at AMI, and we are talking about AMI here, then the type of communication which we see, it's constant communication has to happen. The meter has to be continuously on all the time, because it's a bidirectional flow of traffic between the meter and the server, and server also can reach out to the meter. Now these things probably were not looked at NB-IoT when the NB-IoT was originally designed. Okay, let's see how NB-IoT evolution happens. But I think some of the important attributes which we need to look before deployment of this technology are, as I mentioned, first is whether the traffic is bidirectional or one way. For example, earlier circuit switch data was there where you only has to pull the data, and there was no two-way communication which was required. So whether we need IPv4, IPv6, bidirectional, what are the numbers of meters which has to transmit the data, and what is the frequency of data transfer? It's very, very important before you decide what technology shall you use. As I mentioned to you, just a minute, so my laptop is connected. Yeah. So as I mentioned to you, if the data has to be transmitted every 5 minutes, 10 minutes, 20 minutes, you very closely need to understand what type of technology do you use. Okay, then what is the amount of data transfer which is required? Then what is the location of the meter where they have to deploy? Because the meters are installed in a basement, etc. So will my technology be able to support, or will the spectrum which I'm having, will be able to support those meters in the basement? I will still get about -90, -95 decibel, decibel strength value, okay, or RSSI. Then we also need to look at the modules the meters needs to support, because if you see today, the 4G modules can support backup to 3G to backup to 2G, but 4G modules or NB-IoT, fallback to NB-IoT, fallback to 4G are not available, or even if they are possible, it is at a very, very high cost. So I think these things has to be taken in totality, and then a decision has to be taken as what type of technology should be deployed for a particular project. I would not say that for every project you deploy NB-IoT, or it could be even a mix and match. It could be 4G as a primary, but at certain locations you use NB-IoT because the locations are quite far, okay, from the main center, or they are too rural, or the number of meters installed are too less, because NB-IoT can travel to larger distances. So I think it is a mixture of technologies which will coexist together, and you would have to understand the type of project, the type of deployment which has to happen. The scale of deployment will decide how we will deploy a particular technology. Thank you.
Yeah, thanks, Bhushan. Siddharth, before coming to you, let me ask Jani the same question. Right, so giving a chance to the RF mesh guys. Yeah, Jani, it's yours.
Yeah, sorry. I would like to first to really think about that it doesn't matter which wireless you are doing, there is a similar things that you need to consider and take into account. And thank you, Bhushan, already covering those. But I really start with the total cost of ownership with my project. So what can you afford? So there's many ways of solving things if you can kind of set the put the money in enough table. And that's the one thing that needs to be decided and known from the beginning, because that will set what you can do. And it's the same if you are buying a car or you are buying a house, you need to set the budget, and then you need to live with that budget. So if I look at the one of the first things, then comes that really the coverage of the communication. And many people kind of have a misunderstanding that the range equals coverage. Those are two different things. So you can have a very good range of the communication between a device in the line of sight, but still you can miss the coverage in a certain places, like you said, push on the basements. That's the most critical points. Or this kind of metering rooms. If you look in how the mesh is working, you pretty much have a coverage where the devices are, because every single meter can work as a repeater. So you improve the coverage also in the areas that you don't typically have a cellular coverage, or you have a bad cellular coverage. Then what comes to the kind of network planning, I think that's one of the painful things with the mesh topologies typically, that because of every single kind of coordinator would have a one network and sub networks, and how do you interoperate and where do you place them? Okay, that's a kind of how you can also implement. So how Wirepas has been implementing our mesh, you don't need, it's a very minimum network planning, because you don't need to decide to which DCU the each meter communicates, and that's dynamic, it's self-healing. And that's a big plus, because this network planning that you need to do even in the cellular side quite often turns quite a heavy investment, and the time-wise takes a lot of time in a RF mesh. So you need to also consider when you're choosing an RF mesh that how much you put effort on those. We have minimized that to the bare minimum. And then the installation. So the person on the ground, that typically they are electricians. They know how to connect the wires. So the whole technology needs to support more or less plug and play. So cellular is a good example that when you turn it on, it connects to the network. Taking into account that someone remembered to put the right SIM card and having a subscription for that. But typically, that's the same expectation that you should have in an RF mesh on the field. When you power on, it connects to the network. No need to do anything else. And that's what we have enabled as well. And then the cleanups. So if I look typical installations everywhere in Europe or in India, there is quite a heavy budget for the cleanups. So someone is doing the installation and then you go and fix it. What we have seen with the Wirepas-based installation is that the more you deploy, the less cleanups you need to do. And the reason is that because you are adding there the more routers, so you have a more alternative ways. So even in the beginning, when you have 1,000 meters, you might need to clean up maybe 10. But if you deploy the whole 100,000 or 1 million, there is very small number that you need to do the cleanups. So you don't need to always consider that you need to heavily invest in the cleanups. Like I think sometimes in the cellular, if you have a black spot, so how do you fix the black spot of the cellular? So you need to find the alternative connectivity most often. And then if you take the RF mesh, people have focused quite a lot in how to get the range between the two devices. The challenge is that the radio technically, it's very easy, because what you do, you increase the transmit power and you lower the bandwidth so that you can actually have a very long range. The problem is that that's the biggest enemy for the density, which is the India. So you have a very populated areas. So how do you have planned the devices in the ISM band to work in a very dense areas? In cellular, you don't have that problem because you have licensed band and the kind of back end is doing that. But in RF mesh, you really need to make sure that it's being designed for the dense population. And then the last thing is the interference. So when we talk about the ISM band, it means that anyone can operate there with any type of devices. And if you look at the Indian regulation, it allows very high transmit powers and up to 1 watt, which is huge. And then it also allows any protocols, anyway, 100% duty cycles. So it's pretty easy that there is someone making a bad behaving devices, which are then affecting a kind of interference in the network. So it's important that the network can locally kind of recover those situations, because even that everything works in the beginning very nicely, it also needs to work tomorrow and after 10 years. So network has to be designed in a way that they can do the local decision making for the connectivity. So sorry about the long pitch, but this is I think the question was really the right one. And these kind of challenges everybody see in the field, and it's about the experience. So experience and the good implementation that removes those obstacles and problems.
Okay, thanks, Jani. I will go with Siddharth next on the factors and the challenges which we will have seen in India.
Yeah, thanks, Vincent. I think there are limited points for me to cover now. Quite a few points have already been covered by my co-panelists, right, on the factors and challenges. But let me add whatever maybe I thought needs a little more deep dive. So as Bhushan and Jani rightly mentioned, right, there are multiple factors. I think some of the important ones are also the use case when we talk about AMI. The kind of deployments that happen, whether they are in urban areas, they are in rural areas, whether the deployment is going to be in a really dense area, right, where the number of meters are going to be, you're talking about 250 million meters here, right, billions of devices. So there is going to be a lot of concurrency that will also be needed at the end of the day, right? So how do you optimize a network in the right fashion to ensure that the throughput, whenever the device needs to communicate? So whenever we talk to, let's say, discoms or end customers, they want to send data, let's say once every 15 minutes or once every hour, where all the entire set of meters you are deployed have to send it out to the HUs or MDM. Right, that's finally, even though the data consumption per meter is very low, but finally at the end of the day, it's a lot of meters communicating at the same time. So I think, how do you optimize your network at any given point of time to ensure that the data goes through? I think that's going to be an important challenge. That's a very, very important factor. And that's where I think it's important to invest in, dedicated nodes at your network and which are dedicated for IoT. You can't really have a network which is serving both the B2C and the B2B ecosystem. There has to be dedicated nodes which have to be deployed, which is something that our focus is on. So that's one. Second is the device ecosystem as well. I think that lots of devices are coming into the India market. How does that evolve? Which technologies does it suffer? What are the cost support? What are the cost considerations? Right? How will the ROI be made for that specific use case? And these are some of the important questions. And the device support is not only from a technology standpoint, it is also from a standpoint of what spectrum it is on, whether it's on 900 megahertz, 1800, 21, 2300, from a cellular network provider standpoint. I think this is something that is critical because we are all aware, right? There are, in India, the setup is circle-wise, and every circle we have different sets of spectrums available, and the deployment will totally depend on the kind of size and scale and concurrency that we are going to see in that market, right? So these are a couple of things that I thought I should add. The third point is also on the interexistency of existing technologies as well as new technologies. There is a huge deployment which is already there in the market today, right? Which let's say discoms are already managing. They are on 2G, they are on 4G, they are looking at NB as well. How do you ensure that the entire ecosystem across these multiple technologies is managed seamlessly? I think that's where, again, a lot of detailed discussions will have to be done along with telecom providers, along with device manufacturers and the SIs and discoms as well, to ensure that we don't create a mess. It's a constructive way of going forward. And lastly, I think we firmly believe standardization is very critical. I think there are standards across the globe. There are GSMA standards, 3UB standards. I think this is really critical so that whenever a new technology is deployed, there is a sense of standardization across, and learnings from various parts of the world can be utilized while deploying these things. So I think these are some of the key factors and considerations that will be important from an AMI deployment in India standpoint.
Thanks, Siddharth. So next, I would actually request Rangel to cover his point.
Thanks, Vincent. I think the Bhushan, Jani, and Siddharth really highlights all those factors and challenges, and I would probably summarize it into a few items that I think the factors that we need to really consider. The first thing I would look at is regulatory and standardizations. So we need the regulators, we need the government to allow flexibility with regards to opening up and expanding the available frequency bands and spectrum in India alone, considering the 250 million meters. Because right now, the 800 megahertz, it's only 2 megahertz of spectrum band. So they need to expand beyond that so that we could allow vendors to be able to, not only on the license, but also on the unlicensed spectrum, to be able to provide more solutions to be able to meet the 250 million deployment. The other one is, other than frequency band, I think flexibility in terms of transmit power. I think Jani mentioned about, the transmit power, and also duty cycle consideration. Standardization that Siddharth mentioned is mainly on, in terms of locking in the DLMS COSM standard or the India's IS 15959 standards, and fixing the data model. So we noticed that most utility and discoms, they have different data models. So that would help a lot in terms of ease of integration if we have a fixed data model that we would implement into the meters vendors. Now, the other thing is the utility know-how and systems integrator also and operators, because they will be operating this smart grid. So there should be skills and knowledge development in the utility itself, proper education of the technology, as well as training and experience. So maybe you can start with pilots so you gain experience for a bigger rollout. The other one is, I would summarize in the networking challenges would be, I would look at it as the 4 C's: coverage, capacity, capability, and cost. Coverage in terms of line of sight versus line of sight, the frequency regulations, the transmit power, and the EIRP limitations. From a capacity point of view, how many number of connections? So I think it comes down to cost, bandwidth and latency, the regulatory in terms of spectrum band, and duty cycle limits. Now, in terms of capability, that would come into your security, quality of service, is it open standard, interoperability, integration, and how are you going to scale? Not only on the communications, but also on the backend system, whether it's on a cloud-based deployment or on-premise for your backend system. And then the cost, whether CapEx or OpEx is being considered, public network or private utility networks, or a combination of both, and then whether you're looking under license versus unlicensed. So these are the 4 C's that I would consider as part of the technology challenge for deploying this type of technologies.
Thanks, Rangel. So I would like to request Anand to give his view.
Right, thanks, Vincent, and thank you, co-panelists. That was pretty insightful. I just take this topic in a different mode. I mean, the answer really depends on which hat you're wearing. And if you're wearing a business hat, then obviously you will want to have an answer that suits your organization. But let's be honest to ourselves and let's wear a technology hat and let's think about this problem in toto and try to figure out what is going wrong for last maybe 2 decades now, where the AMR adoption has never really democratized as such. Now, if we see these problems, there is an evolution of technologies that happened, and I was part of some of them right from 2009-10, when Zigbee was supposed to be one of the options for AMR-AMI. Well, that didn't really work. Then moved on to RF, then sub-1 gigahertz RF. Someone came up with LoRa. Now, these are multiple technologies, then 2G, 3G, 4G, all these technologies now in the IoT. These technologies have really, we're just talking about technologies year over year. Every couple of years, a new technology comes into place and then we start running after it. But no one really thinks whether that's going to work. Now, what are the challenges we've learned? And, now that, we've almost spent 2 decades learning about all this in an Indian type of scenario, let's figure out what are the challenges, and those have happened so far. The first challenge, upfront infrastructure cost. Now, any type of non-standard communication, you have an upfront infrastructure cost in terms of erecting gateways, canopies, towers, and then also maintaining it and making sure that there is personnel available for doing that. The issue regarding provisioning, and Jani rightly pointed out that it has to be like plug and play. How do you do? Put a device and it starts communicating to the cloud server. It doesn't need a commissioning. If something comes up in between, it doesn't really need to have a new coordinator or an access point coming to it. So all these things, you really need to take care of when you're designing the network. So that's the one bit when it comes about, talking about localized or proprietary technologies. But the similar problem is solved when you go to cellular technologies, because you don't really have any investments going into it. But when cellular technologies come into it, then you have mobile operators operating the same bandwidth as well as the IoT devices. Now there is a war between these two set of devices, and again the experience goes for a toss. The issues related to reliability are obviously there, and we've again seen how that legacy technologies have behaved in actually transferring the data or giving you the QoS, as we call it, to the end consumer. And that's where the need for backup came in. So if you see, an aeroplane would need a backup of another engine because the risk is way too high, but a car wouldn't need. Similarly, AMI is a type of application. You wouldn't really need a backup to provide, from A to B. It's there, it works, or it doesn't work. I mean, having a backup only would increase the cost of adoption of the technology. Like you have two different technologies and then two different RF sections, maybe the chipset could be, one or two based on what type of technology you're using. But if you try to solve the primary problem, you don't really need the secondary technology in the first place. And that's where the industry should be focused on getting the things right in the first place and not looking after plan B or C. So from that perspective, we've kind of studied all these aspects relating to, Bhushan also mentioned about deep penetration into the basements or indoor penetrations. So which other technologies which will help it is we have to come out with. Now, NB-IoT was designed by 3GPP standards, and by design, it is meant to have 20 dB of additional power. That means it would reach places where even no other cellular technology would reach. It is got that deep indoor, deep basement penetration to give you that data, which will be available probably in real time as well if you use or utilize the near real time, if I may say, the technology in a right way. And I'll come to that in a bit, how to use that about in a near to real time scenario. On top of that, Geo operates at 850 megahertz in almost all of the circles, most of the circles, I would say. That means the penetration is further increased as it is even lower than the sub-1 gigahertz frequency that is being offered. So from these angles, we think that, and if I'm just about to wear a technology hat, and if all of us were, to cover our faces and the organization logos, we would really come to a conclusion that NB-IoT is something that has been indeed designed for, addressing challenges that legacy cellular networks have been facing. And that's the reason it's also being adopted by the 5G standards as well. Now, yes, there is a problem in NB-IoT when it comes to how you transfer the data, because you have limited bandwidth, the latency is low. But then there is something called as NIDD, non-IP data delivery. So what it does is it takes up the beauty of RF and the reliability of cellular and gives you a amazing end user experience where all the payloads, like, if you talk about the DLMS payloads going over a TCP IP stack, you would be thinking of around, 300 bytes of data transfer and at least 3 or 4 connections made to the server of the head-end system from the perspective of sending data. But with NIDD, all that is reduced to like probably 1/5 of what data would be required. So around 20 bytes is something that you would require as against 300 bytes, and the number of transactions would be just 1. Again, an IDD is nothing which is proprietary. It is a standard thing defined by 3GPP, the likes of Cisco's, and all of them have gotten their NIDD servers. Anyone can adopt and use that. So these are some things that can be used by the industry, and especially the AMI smart utilities industry, to come up with NB-IoT or reliable data communication. So that's something I think I had my perspective on. Maybe I'm open to discussion on these, but yeah, that's more or less from my side.
Thanks, Anand. Actually, we all heard about what are the challenges we see in this particular AMI space. I think from my perspective, actually, there is one point which I wanted to add to what all others have spoken, is also an end device integration. When I say end device, I'm talking about the smart meters, because to cover this 250 million meters, we need to have multiple smart meter brands. To do that, actually, we need to have an integration process. That itself is going to be a big challenge for many of the utilities. So before we go forward, actually, I would also request all the viewers to give the questions, and you can leave the questions in your QA tab, so that towards the end of this particular discussions, we can have further discussions. So let me come back to Siddharth, actually with a question like, what is the role of a connectivity for success of AMI project?
Yeah, thanks, Vincent. So I think we all agree that connectivity plays a crucial role in any IoT use case, and in AMI, again, it forms the backbone for its success, right? If your data is not coming to the cloud, to your platform, I mean, the use case doesn't fly. And this has been exacerbated further with the pandemic around us. Data, people are not able to fetch data manually, and billing has been an issue, cash flows has been an issue. So I think this is something that is really, really critical, right? Now, when you say what is the role of connectivity for the success of AMI, I think there are a few critical questions which we need to answer, right? What is the right technology for scale deployments like AMI? What is the flexibility that can be offered to customers, right? And then third is, what is the future readiness? You're today investing in your devices, in your platform, in your devices hardware as well. How are you securing those investments? How are you making them future proof? I think these are some of the critical questions which are to be answered. Connectivity again plays a very, very important role, right? As I mentioned earlier, again, it is important to solve all these problems with the right technology. It is important to listen to the customers. What are the challenges they're facing? And I think that's where flexibility is very, very critical. I talked about, and even my co-panelists talked about deployments in densely populated areas, coverage as a challenge, need for concurrency, the kind of power consumption, battery life that you're looking at, depending on what kind of meters are being deployed. I'm talking at a larger level right now, not just electricity meters, but power and gas meters as well, right? So I think all these things have to be looked at. And from a communication standpoint, I think the technologies that have been here for so many years, right? Whether it's 2G or 4G, I think these are some of the tried and tested ones. These are mature technologies which have service utilities. I think the use cases have been so brilliantly using them. And at the same time, again, as some of the panelists also mentioned, right, there are new technologies which are coming up, which are also important. At the end of the day, I think depending on what kind of data you're fetching, what is the frequency that you're fetching it at, what are the kind of deployments that you're having, I think you'll have to have flexibility, and you have to listen to a customer backwards, all of us out here, right? And that flexibility and choice is very, very critical. At the same time, when you're talking about investments to be done in hardware, I think one thing that we are also working on is something called as the eSIM or EUICC technology. These are all remote deployments, right? EUIC is something which we don't hear in AMI as often. That is typically being heard on the auto sector. But I think, are there any learnings from that sector which can be brought here? We are deploying in remote areas. If there is a challenge from a connectivity standpoint, I think this technology gives you flexibility of switching over the air. I think these are some of the new things that can be explored in AMI technology as well. Third point is reliability at the right cost. I think all of us here agree reliability is critical. Yes, SLAs are important, but at what cost at the end of the day, right? That's a very, very important question to be answered. We as telecom operators or other panelists on the forum today, all our companies are investing. But then there is an expectation. India is particularly a very cost-conscious market, right? And things is, we hear that the consumption is really low, the rates are supposed to be low. But then when we compare it to global standards, we need to understand the rates are very different out there. So as an industry, we need to collectively decide what are the right price points that we can operate at, right? Otherwise, it will not be a win-win for all of us. So I think that's something that is, again, very, very critical. And lastly, I think I spoke about this earlier also, but standardization across whatever we are doing. When you're deploying these many technologies or your devices across multiple technologies, I think the more you standardize, the more learnings you take from global deployments, that will simplify our life. And that is the focus as we as a company are trying to, adopt. Yeah, so that's the answer.
Yeah, thanks, Siddharth. So, Jani, I will come back to you with another question. It's basically on the specifications for communication. Do you think the current specification for communications are sufficient to handle large-scale deployment of about 250 million meters?
Honest answer, no. I mean, it's good for today when there's a limited amount of devices out there. But like the standard has been written, I think that's not ready for the mass deployments. And I'm not saying that you cannot have a good implementation inside of that, but that allows also the implementation that are not ready for the future densities and the fact that not that only the own utilities network will be operating there. There will be plenty of others, and there's things that can be sorted out easily. So there is unused spectrum like a 1.9 gigahertz. Which is available and could be added and a part of the specification, and that's part of the ETSI standardization, part of ITU. So there is a ways of adding the unlicensed spectrum to utilizing that, and I really come to the fact that I'm a big favor of the mobile. I really love the LTE technology, and most of our customers which are using the DCU, they use the LTE to consolidating the 1,000-meter data to the LTE, which is the by far the best carrier to kind of transfer that big chunk of data over the LTE. So I'm not saying that the mesh is best for everything. I think there's a purpose for every single connectivity in the planet, but is the standard ready for the big deployments? No. I think that India doesn't have a history of 20 years of smart metering. In Nordic countries, we've been doing smart metering 20 years. So there's already the 4th generation of the smart meters deployed since 90s. So there has been PLE, cellular, different kind of RF technologies. Now there's a next generation RF. So there's a lot of experience, and also the experiences are coming in higher layers. I think it was Rangel talking about the application layer data formats. That's exactly the learnings, that they get this standardization as high as possible, because then it allows that you can actually solve the problems more versatile ways. But then in the interoperability comes when you have a highest level standardized. So it doesn't matter which systems you basically bring into, they all interoperate. The lower you standardize, the harder it's actually make the interoperability. So that's the learnings from the many places.
Thanks, Jani. The next question actually I have was actually for Bhushan. Basically, this is on the, we are seeing a lot of tenders coming out from the utilities for the AMI. So basically you are representing a TSP now. So our TSP geared to bid the AMI tenders across different utilities. Do you have the capability as an SI and understanding of the complex system?
Yeah, thank you very much. Before I answer this question, I just want to add one more point to Jani's question which you had. And since we have like-minded people here, I definitely want to put these 2 points, because a lot of people who are listening to us. One is, your question was on the meter specifications, correct? And yes. I'm telling you from my experience that currently there are 2 big challenges which are there. One, the telecom operator has not been taken into confidence before releasing the communication guidelines to the DISCOMs. So Ministry of Power, SDNM, who are designing these, the communication capabilities, probably needs to take telco also into the loop, because currently the way the communication methodology has been defined. It is always on. It hogs up the network. Okay. So due to which what happened, some meters are continuously trying again and again and again, leading to the hogging of the network, due to which the other meters are not able to transmit the data. So that's a big challenge which will happen, or which will happen not only on 4G, but even on NB-IoT also. So this point needs to be looked into. Secondly, currently in the BIS standards, SMS is not allowed. SMS has been blocked. I think SMS is a very, very useful medium in case the primary medium is not working or the data is not working. You can send a message over SMS, for example, RC or DC, or maybe even local remote troubleshooting. Today, the meters are being called smart, but you'll be surprised that you have to physically go to switch on, switch off the meter. You can't do it remotely because the SMS channel has been blocked. So I think these are two important things which should be brought, in these discussion and in the meeting specification. Otherwise, I feel that the current specifications are not good enough to handle that much amount of meters volume which will come up. Now, coming to this question, are the telcos ready? I would answer. I have 4 points to make on this. First of all, if you have to do something new, you should always look at the past. As what are the mistakes which has been done in the past, and can we correct that in the new after. So I think if you look at RAB, DRP, the telecom service providers, TSP specifically, while there were different people, SIs were there, MDAS provider was there, NSPs were there, but telecom service provider was never included into the RAP, DRP specifications. So what happened after that? You see, connectivity, as Siddharth said, connectivity is the major element. The meters, the HES, the MDM are all static pieces. Connectivity is the only one which is changing continuously. If you may get a connectivity in the morning, but you may not get connectivity in the evening, because connectivity expands and contracts depending upon the number of devices which are connected to or devices of people connected to the network. So it is very important that the connectivity specifications are kept into mind, while designing the overall specs. So in RAP, what happened? The telcos were never consulted. So what happened after that? The acquisition rate hardly was 60-70%. Even today also, they are hardly able to reach to 90-95%. Although this RAP DRP was released almost about 10 years back. So I think we have to learn from RAP DRP. That's how important is the connectivity. While connectivity piece could be small in terms of revenue, but the amount of impact it has on the operations of the business is very, very large. According to me, based on my experience in working with the large discom today, almost 60% of the issues which comes up is because of the communication module issues, is because of the connectivity. So it is very, very important to have telcos clearly being in a guiding force to define as how do they handle the connectivity issues. As Anand also mentioned, you can't get coverage everywhere in the town. While NB-IoT definitely is a great technology, but even then NB-IoT may have its own challenges. Okay. Second point is even SDNM. SDNM defines meters, connectivity, and the system integrator are the 3 pillars, for the AMR metering or AMI metering. So I think even they are acknowledging that the telco can lead bid or be the front lead bidder for the tenders in their draft. Number 3, TSPs, if you see, telecom service provider, they are no less than a utility. They are also doing the same business, but the only difference is that we use telecom waves to provide services to the customer. Okay, but we also have a service mindset. It is imbibed into us. We are a system integrator. If you see our system, they are very clear. They are very similar to the metering system. We have a billing system. We have our mediation system. We have our CDR system. The network systems, who provide the CDR to the customer, to our network systems or to our billing systems, and then we create a bill. The HES is equal to mediation system in telco. The MDM is equivalent to the billing system in telco system, which we call it MDOCS, which is the name of the company whose system we deploy. So we understand this business very well. We understand the prepaid business. We understand the postpaid business very, very well. We understand we are ourselves an SI. All telcos, and I'm not saying from VI perspective, Airtel, Jio, they all are big SIs in their own way, and they are doing almost similar business. And the last point which I would definitely want to put is the financial strength. These tenders are long-term tenders, 8 years or 10 years. Telcos have deep pockets. They can take financial hits for a few years and maybe burn some cash for some time to ensure that the services are rendered properly to the customer. So keeping these things into mind, I think telcos are very well, they are very well advanced. In fact, I would say all telcos as technology service providers, they are all technology service providers. They are no longer telecom service providers. So I would strongly recommend and suggest that right now, telcos are in a very, very good shape. Connectivity is extremely important. SGNM, SGNM recommends telecom service providers to lead with. Telcos has SI capabilities and the billing capabilities, and they are themselves a utility handling 25 crore customer or 40 crore customer, 30 crore customer. And telcos have got financial strength and capability to handle long-term contracts. So yes, we are ready to take up these products as a lead bid. Thank you very much.
Thanks, Bhushan. So let me get back to Rangel with another question, which is actually also going to cover this particular 250 million rollout challenges, which we'll see. Considering the large-scale deployment, 250 million meters in the next 3 years, what communication technology would be the best bet for the future?
Thanks, Vincent. I think firstly is I don't believe that a single technology can address this requirement, considering we have 250 million. So I think like what Jani and the other guys mentioned that multiple technologies would coexist. So communication technology has advanced to the point where every smart grid applications, irrespective whether it's smart metering, distribution automation, substation automation, and some others that might emerge in the future can be supported by multiple technologies, combination of technologies, multi-tiered, open standard, and I think it's going to be IPv6, considering you have 250 million. IPv4 would definitely not be able to take that on as part of the communications platform. Backward compatibility, say for example, you're implementing 5G, are you backward compatible to 4G or 3G for the purpose of a particular technology would sunset? And then at least you have the other technologies that would support your applications and avoiding the sunset and the track roll of replacing those modems or communication modules on the meter. Now, those utilities that deploy a ubiquitous high-capacity communication network will be positioned to deliver connectivity-driven outcomes in a wide range of domains. So not only smart metering, now utilities and discoms are already asking, can I do DA with your infrastructure? Can I do smart street lighting? So they're not looking only on the AMI. So I think service providers or communications providers should look into an overall application, not only concentrating on AMI, but beyond that, PA, SCADA, smart street lighting, and more. So utilities, system integration, solutions provider must understand the full set of networking capabilities that might and will be ultimately required in the future. A failure to do so with an initial application creates the likelihood of stranding your asset and incurring future upgrade costs, and more or less you would have those track roll. So the balanced approach, I think, is not on a single technology, but multiple technologies. So therefore, putting in the right smart grid platform from the beginning to be able to handle not just smart metering or the applications of today, but also of tomorrow. And then the risk of cost of such an approach, you can simply would simply be prohibited. So have a look at it's a combination, and I don't think single technology would be able to address that 250 million requirement in India. So it would be a combination of private communications, be it PLC, RF mesh, RF point to multi-point, cellular technologies, combination of 2G, 3G, 4G, NB-IoT, 5G, LTE, and so on. So I think there's a lot of room for every to be able to play in this role. But then again, you have to make sure that it's open, standard communications, and you have to have a certain set of specifications and standards, just like what the data model would be. I think Jani mentioned that again, reiterated. We have to have a certain data model specifications so that all this communications technology would just adapt and then would be able to support each and every application that would be required now and in the future.
Thanks, Rangel. So before I go into the question and answer session, actually, the last question I have for Anand, what initiatives TSPs are doing for the AMI rollout?
Sure, thanks, Vincent. See, the biggest problem till now, if you see what is happening is we as telecom providers have been only saying that we provide connectivity as a service. And then we move out saying that we have connectivity here or not there. There is some problem with the NIC card or the head-end is not working and so on and so forth. So the biggest thing that we should now do to turn this industry around is offer data as a service and not stop at connectivity as a service. By what it means as data as a service is you take a one-stop shop or a one-stop responsibility, to be precise, to pick up data from the meters and push it onto the head-end system and then provide it to MDMS using some APIs. If anything happens, the telco is responsible. And to answer to your larger question that you asked to Bhushan, are telcos responsible for system integration job? Yes, they will be equipped for this kind of a job only if the first baby step that take is to provide data as a service. If you're not providing that, that means we are just trying to, increase the number of connections and say that, okay, the revenues of these organizations have gone from X million connections to Y million connections. That's about it. So in my opinion, and that's what exactly we've been doing. So we've integrated with a bunch of electricity meters, all of them, most of them Indian, some of them foreign international energy meters. So around 16 energy meter manufacturers or OEMs are integrated with us at some or the other level as of today. Obviously, we have connectivity in terms of NB-IoT and NIDD on top of it. And then we are also deploying our head-end system to provide data as a service rather than just pure connectivity as a service. For utilities, for system integrators, it becomes a one throat to choke. It is that telecom service provider. We can't shrug our responsibilities and run saying that, okay, there was a problem with NIC or, the head-end. So this is one of the biggest initiatives or the methods that we need to adopt to make sure that the AMI, AMR infrastructure is actually, capable enough to serve to these kinds of needs of connecting to 50 million odd meters. So I think we can talk about smart grids and all and how this can be enabled, but if you don't take the first baby step of actually ensuring the reliable data collection from the meter to the head end, I think every other talk will be just a theoretical discussion and it will lead us nowhere. So I think we should take a first step by providing that SLA that a utility needs, not a SLA that is defined from a telecom perspective, that the tower needs to be uptime to be up for say 99.99%. What does the utility do with it? The utility should have a data guarantee of whatever 99.99% all the time, whether it's a tower, whether it's an RF mesh or whatever it is. It just needs to say, I need data. And as service providers, we need to provide data. If we make this as simple as this, I think the jobs of all the people in the service industry will be really easy.
Very well said, Anand.
Thanks, Anand. I think from my side, actually, most of the questions I had was covered. In fact, we have got some few questions. Actually, the first question is basically on NB-IoT. So I'll actually lead this particular question to Anand. On NB-IoT, do we see any global deployment for electricity discoms, considering FOTA and bidirectional communication challenges? So I have this question for Anand.
Yes, some of the European countries have already deployed NB-IoT and they've started the rollout. In fact, one of the biggest telecom operator who's also part of Indian ecosystem, has their website that talks about NB-IoT and the advantages of NB-IoT as well. So that's being adopted. Now, when it comes to FOTA and two-way communication, yes, that's also being tested. In fact, one of the leading private utility service providers in India, we've tested everything, right from FOTA to two-way communication, the time taken for FOTA, everything is recorded, and post that a tender of 500,000 meters was released. So after thorough testing of NB-IoT at various places, basements, nook and corner of the building, all these things, then came the tender, which actually spoke about how NB-IoT could be, utilized for that smart metering industry. So a simple answer is yes, it is being adopted globally. And the second answer is yes, it has been tested. And in fact, we have tested here in India, and we can, provide the test results to any utility who's interested. Just connect with us, and we'll showcase all the results.
Thanks, Anand. Can I request, admin, is there any questions from the viewers?
Well, I think that was we have few more questions.
Okay, can you please forward the same?
Yeah, sure, definitely.
Okay, the next question is actually, what is the best suited communication hybrid model for the Indian smart meters? So I'll add, in fact, this was addressed very briefly by Rangel. So I'll ask this time Jani to address this particular question.
Of course, I might have a bit subjective answer, but the RF mesh it would be my choice, majority of the communication. So I'm not saying that it would need to be the 100%, but we've been proven that you can actually run a very, very dense implementation with the RF mesh, and then basically you can copy paste that. So if you prove it that in a 1 million devices in a 1 square meter area, you can pretty much then scale it that to any sizes of the city. So RF mesh, and then also the looking at the cost structure in India, so it's quite demanding. So how do you kind of live with that? And I already been seeing that in some of the European countries where they roll out the NB-IoT, the one of the struggle is that it's not spectrum efficient, because kind of how you use that to transmit the data, and then gaining the money out of that service, compare it that you sell a connectivity for the LTE with the higher transmit power, higher throughput, you can actually sell more data. So that has been the struggle for the operators in European countries, that how they monetize it. And then if I look the kind of just the spectrum as a national resource of the India, you have such a big population that the data amount that they are consuming only for their mobile use will use the spectrum. And then the operators need to look at how they use the spectrum efficiently. So it's not that the NB-IoT is not good for the kind of penetration, but I'm just purely looking at if you go for the 10 years, so how do you use that spectrum? Either you find the new spectrum to use, which I always like to compliment, that if you can locally utilize the ISM bands, like we already seen that many of the operators are transmitting even the data over the Wi-Fi. If you go in Tokyo or Seoul, that's already happening in parallel with your cellular. And that's what I see also in IoT and the smart metering market, that you need to utilize the ISM bands, but you also need to kind of do it in a way that you are preparing the high density of those ISM devices coming out there. In a 2.4, it's not the problem because of the range so much, but when you talk about this high transmit power and sub gigahertz, you need to take that into account. And that's why I also bring it up, this Tech 2020 new standard, which was designed for exactly these use cases in ETSI, in ITU as a part of the 5G, really meeting this corner. And there is a spectrum available in India, which is 1.9 gigahertz, if the regulatory people are just adding that as a part of the regulation.
Thanks, Jani. Looks like I think we don't have any further question. Can you just confirm once again?
I think that was the last question, gentlemen.
Okay, thanks. Thanks a lot, everyone on the panel. Actually, it was a great discussion. So I'm 100% sure most of the utilities would have heard about us actually discussing on this particular communication platform. As you all know, actually, the two-way communication platform, which is very actually has to have a high reliability network to bring the metadata to the head-end system. And as mentioned, we need to have actually a detailed discussions with the industry leaders to come out with some kind of an open and standard with a standard data model for the meters. So thank you, gentlemen. Thank you very much for being on the show. And thank you very much, organizer.
Thank you, everyone.
Thank you, everyone. Stay safe.
Thank you, everyone.
Bye.
Very amazing session. Thank you.
Have a great day ahead. Bye.